So today we're going to solve a system of equations by using matrices and row operations. So before we start this, let's just review some row operations. There's three of them. Basically, the first one, remember, is you can flip any two rows. The second one, you can multiply any row by any non-zero number. Right? You cannot multiply a row by 0, but you can multiply by any non-zero number. And then last, you can add any two rows together. And you can combine these together. So you can like multiply a row, then add, or you can add two rows and flip. You can combine these three things, but these are the three things that you're allowed to do. Flip, multiply, and add. All right. So, when you're solving a system of equations by using row operations and matrices, your first step is to rewrite this system as an augmented matrix. We did this 2 assignments ago. So remember, you put your x coefficients in your first column. You put your y coefficients in your second column. You draw a line here. And then over here in the third column goes your constant terms. So this system above, written as an augmented matrix, would look like this. So now here's our goal. What we want to do is we want to use row operations to change this matrix right here into this matrix. 1, 0, 0, 1, and then you got numbers over here. So basically what you want is you want ones along that diagonal there. Okay? And then you want zeros everywhere else. And then these numbers over here are going to be the solution to the system. Okay? Now when you're doing these, when you're trying to get it to look like this matrix, where you got 1, 0, 0, 1, and then numbers over here. There's a process that you want to go through. Usually what you want to do first is always try to get this element here to be a 1. Once you get that element to be a 1, then move down here and get this element to be a 0. Okay? And then third, you want to get this to be a 1, and then last, get that to be a 0. Okay? So, let's try to do one of these. So I'm going to erase this. Remember what our goal is. Our goal here first, my goal first is to change this into a 1. I want to try to avoid fractions if I can. Okay? You can't always avoid fractions, but we're always going to try to avoid fractions if we can. So remember, this is row 1, this is row 2. Somehow, we got to use those row operations. We can use a combination of them to change that first element into a 1. So what we could do is we could take row 2, add it to -1 times row 1, and then replace row 1. So we're going to take -1 times row 1, and then add that to row 2, and then that's going to become our new row 1. So what we have here is row 2 staying the same. So just bring down row 2. We're not changing it. So what am I doing? I'm taking -1 times row 1. So if you multiply row 1 by -1, it's just going to change the signs of everything in row 1. And then what we're going to do is we're going to add this new row 1 to row 2, and that becomes our new row 1. So negative 2 plus 3 is 1. Negative 3 plus 6 is 3. Negative 5 plus negative 6, negative 11. Okay, so we got the first step done. We got a 1 here. So now we want to move under the 1. We want to change this element right here into a 0 by using our row operations. Okay? We got to think about how can we change that into a 0 without changing anything else. Okay, so what we're going to do is we're going to use this 1 that we got here to get this to be a 0. So we're going to multiply row 1 by negative 3. When I multiply row 1 by negative 3, it makes this element right here a negative 3. And then I'm going to add that to row 2 and then replace row 2. Okay? So I'm just going to write it up here. So what row am I replacing? Row 2. So that means row 1 staying the same. So copy down row 1. It's 1, 3, negative 11. Now what are we doing? We're multiplying row 1, which is this, times negative 3. So 1 times negative 3 is negative 3. 3 times negative 3 is negative 9. Negative 3 times negative 11 is positive 33. And then I'm going to add these two rows together here, the one in red and the one in blue. And then that becomes my new row 2. So we get 0, negative 9 plus 6, negative 3. 33 minus 6. Let's see, what is 33 minus 6? 27. Okay, so let's see how we're doing. We got a 1 in this position. We got a 0 in this position. So now I need to work on this position here. I need to change that negative 3 into a 1 by using our row operations. Okay? So the easiest way to get this to be a 1 would be to take negative 1/3 times row 2 and then replace row 2. So let's see what we got. We'll take a negative 1/3 times row 2 replacing row 2. So that means row 1 is staying the same. So just copy down row 1. 1, 3, negative 11. Now I'm going to take negative 1/3 times this whole row. You got to multiply everything by negative 1/3. So negative 1/3 times 0 is 0. Negative 1/3 times negative 3 is 1. Negative 1/3 times 27 is negative 9. So we're almost done. So we got 1, 0, 1. So the last thing now is to get that last element there, this element here. I want to get this element here to be a 0 without changing any of the other ones that we already changed. Okay? So what we're going to do is we're going to use this row right here, row 2. We're going to use that row to get rid of that 3 there. So I'm going to take negative 3 times row 2. And then I'm going to add that to row 1 and then replace row 1. So let's bring this down. See what we got here. So I'm replacing row 1. So that means row 2 is staying the same. So copy down to row 2. It's 0, 1, negative 9. Now what am I doing? I'm multiplying row 2, which is this one, by negative 3. So when you multiply that by negative 3, you're going to get 0, negative 3, 27, negative 11. Negative 3 times negative 9 is 27. Okay, so let's add these together. Adding these two rows right here. 1 plus 0, 1. 3 plus negative 3, 0. Negative 11 plus 27. Is 16. So what this tells us is the solution to the system above. Remember, this right here, if I was to rewrite this, make this augmented matrix here as a system, it would be 1x plus 0y equals 16. The bottom would be 0x plus 1y equals negative 9. And since we have 0y, that's just 0. And 1x is just x. So what we got is x equals 16. And down here we got y is equal to negative 9. So the solution to this system is the point 16 comma negative 9. So again, here are all the steps. Here are the row operations that we're allowed to do. I'll leave this on here for a little bit.